And welcome everyone to Learn a Trade. My name is Kevin Tate, and I'm glad to be here with you all today. Hope all is well with everybody. Today's broadcast is called Steps to Repair a Turbo Chef Oven with Mag 3 era. That's Magnetron 3 era. I'm going to go over, I have a few clips that I took on a job site that I was doing a Turbo Chef repair on. And I figured I could go over a few of the steps to take when troubleshooting this issue with the F3 Magnetron current era. That's a Magnetron current low. So most times in those cases on Turbo Chef, you'll have the Mag 3 eras, and then they'll be logged logged in the fault history. You can look in the fault history when you go into the service menu, and it'll have the specific number of magnetron errors that it's had. And what is happening when that magnetron error comes up, it's a low current. It's reading a low current. So the current sensor, which is called the CT sensor on the main board, that sensor is not recognizing the proper amperage on the high volt side of the circuit. So if it's not sensing um, above 14 or between 14 amps to 20 amps, then it's going to go into that F3 error low message. And normally you're looking for a range on that amp draw of between 14 to 17 amps. And in my opinion, 17 is still a little high because that high volt circuit works on a 20 amp slow blow fuse. And to me, 17 amps, there's possibly some other issues going on within the high volt circuit that would have to be looked into. But normally, for the machine to get back up and running properly and cooking properly, you want between 14 to 17 amps on that high volt side. So I'm going to get into a few of these clips on the Magnetron code, and then we'll go through a few of them and see. But we'll go through all of them and see what we got. I'll probably be stopping and starting and stopping here. Give me a second. Let me get that lined up. Okay, so you saw the screen there, which is also the screen on the display screen behind me. It says F3 Magnetron current low on it. And right over here at the blue arrow, that's your K2 relay. Okay, there's no sticker on it because this relay has been replaced before. So there's no sticker. These here with the stickers on them, the K7, K1, K3, K6, those are all the original relays. But this K2 relay has been replaced before. But this relay is shorted. It's right over here. The short is actually right over here on the left side contact. That contact you'll see later on is burnt. So that's an indication of a bad K2 relay. And this is one of the first things you want to try to look at, is look at your K2 relay. Take that right side panel off of the oven and then you'll see it right there. Unless it's a newer model, this is an older model. If it's a newer model, like one of the the bullet models, then your relays won't be on the right side. They'll be up top. They'll be in the top, connected into the circuit board up top, and you can't miss them. You just take the top panel off and you'll see them. That's on the bullet unit. But this unit here is an Encore unit. It's an older unit, and the relays are all on the right side. So you can take that right side panel off, take a look at your K2 relay, see how the contacts are looking. See, you can see they have a clear covering over them, so you can see, like, if they're burnt out, you'll see like a smoky, hazy look to the inside the relay. And usually, if you see any discrepancies like that, like uh, dark, like black soot around the inside of that, or the contacts, these copper contacts here, if you see those discolored, that usually means you have a bad relay. You have a shorted relay, or a, and it's a bad relay. And more than likely, if you have a bad relay, this fuse right down here, we'll be going over that in a few. This is your 20 amp fuse. These next two fuses above that, this is the 12 amp fuse just above that bottom 20 amp fuse. And then the top fuse is also a 12 amp fuse. So you have 12 amp fuse up top, 12 amp fuse in the middle, and you have a 20 amp fuse or a 25 amp fuse on the bottom. Now, on the Encore units, you usually want to use the 20 amp fuse. Those have always had 20 amp fuses in them. The newer model units, the bullet units, those come with either a 20 amp fuse or a 25 amp fuse. It depends on when they were manufactured. And then next step right here is, after you recognize you have a bad K2 relay, you want to go down with your ohm meter, and you see the blue circle. The blue circle is indicating the 20 amp fuse, and you want to test that 20 amp fuse to see if you have continuity. More than likely, you'll have a blown fuse there, and you'll need to replace that blown fuse. And then right here, you want to go up to the top of the machine, and you want to test out your high volt transformer. This is my meter sitting on top of the transformer, and my probe is on position terminal number 4, right? The blue circle on the left there, and then the blue circle down in the bottom right. That's I have that attached to a chassis ground. So you want to go from ground to the number 4 terminal, and you should get between 55 to 65 ohms or K ohms. If it's lower than that, if it's down in the 40s or 30s, you definitely have a bad high volt transformer, and that will need to be replaced. So you want to measure your high volt transformer at terminal 4 to ground. And if you want to go further, you can remove the 3 terminals on the bottom of the transformer, terminals 1, 2, and 3, and you can go from terminal 1 to terminal 2, and you should get 0.08 to 1 ohm between positions number 1 and 2 on the lower terminals of the transformer. That's just an added test. But if you test out your terminal 4 to ground and you have a good reading, then more than likely you're good to go, unless you see that there's like burn damage on the transformer. If you see any burn damage on the transformer, you should definitely replace that transformer. And then next, I always check. Let me go back here. Sorry about that. Right here, I always check both transformers. This is the transformer on the left side. I've already checked the transformer on the right side, but now I'm checking the transformer terminal number 4 to ground on the left side, and I have 65 k ohms, which is good. So you just want to check both sides, because when you have a F3 mag error, there's no telling which magnetron circuit is bad until you test each side of that circuit. So you're doing two tests at the same time, left and right tests. And that's still me checking the ohms on the left side transformer. And this right here is the K2 relay that I was talking about. And I'm not sure if you could see it that well, but on the left side, that copper contact there, a little contact. You see the contact on the right? It looks clear. You know, it's you can tell that it's clear. The one on the left, though, you can see the discoloration in that copper contact. So that's telling you that there's a short on that side of the relay. So you will want to replace that relay. Right here is the insulated CT loop. Okay, this right here is very common. Where you see the arrow at, the blue arrow is showing you an opening in the insulation that's over those terminals. And the thing is just to be on the safe side, especially when you're working with a unit that has over 2,500 volts going through it, you want to make sure that your wires are insulated and secured. This one here, even though it's a small opening, that's enough for you to get hit with electricity if you touch that, if that ends up touching to the metal brackets or to the body of the machine. So you want to make sure that you have that CT loop insulated. You can insulate it with the shrink insulation, the heated shrink insulation, wire insulation, or you can use electrical tape and just make sure it's covered, make sure it's insulated. Right here is a waveguide. This is a waveguide, and I'm showing you a picture of the inside of that waveguide. When you have a Mag 3 error, it's good to take your magnetrons off on both sides and use your flashlight to look inside that port, that opening on the waveguide. Because if you see it like this, you see how sooted up it is in there. It's like black. It's built up with grease, and it's just really built up in there, and that is going to cause the magnetrons to arc. Okay, so when that happens, when those magnetrons arc, that's going to cause that K2 relay to short eventually. And then it's going to cause that 20 amp fuse to blow, because it's going to, once it arcs, it's going to pull more amperage. So you want to be sure to check your wave guides. And if they're dirty like this, everybody, if they're greasy and contaminated like this, you want to replace that wave guide. If you're in a position where you don't have a replacement wave guide, what you can try is, you can always try to spray some cleaner in there. And when I say cleaner, it's best to use the manufacturer's cleaner. The Turbo Chef provides, every location that has their equipment, Turbo Chef provides them with cleaner. So it's in a white bottle with blue writing on it, and it's what they prefer you to use on their equipment. So try to use that. If you don't have a replacement wave guide, try to take the wave guide out, spray it down with that Turbo Chef cleaner, and let it just sit in the water with the cleaner in there. Let it soak in there while you're making other repairs on the machine. And then you're gonna have to go back to it, and then use a scrub pad. And you'll also need a long slotted screwdriver, just to push and work the scrub pad around inside there. Sometimes it's tough to get those cleaned after they've been contaminated like this. But if you're in a bind and you're trying to get the machine back up and running, you can always try to clean it out. If you clean it out as best as you can, and you still see that there's contamination in there, then I just recommend that you'll have to keep the machine down and until you can come back with 2 new wave guides. And I'm saying 2 new wave guides because if one side is contaminated, it's pretty certain that the other side is going to be contaminated. So you might as well replace both wave guides. And for like independent service providers out there, if you have a customer that has one of these units, and you need to come back to replace the wave guides, you can give them a quote, once you get the prices for everything. It'll be good to, give them a quote ahead of time for 2 new wave guides, 2 new wave guide glass. That's the wave guide windows that I've shown on other videos. I'm not sure if I do show it on this one later on, but you want to try to quote out the 2 new wave guides, 2 new wave guide glass, and 2 new wave guide glass seals. And the seals go onto the glass, but they're sold separately. So you want to make sure you get that all into your quote if you're independent service provider and you're working on your own. If you're working for a company, then the best thing to do is you'll have to leave the unit shut down, explain to them that the part will have to be ordered, and then you'll return once the part is ordered. Because if that's not replaced, and you change out your relay, you change out your fuse, and you change out even your magnetron, if it's in the contaminated wave guide, within a couple of uses, that magnetron is going to arc out again. The new magnetron is going to arc out, and then you're going to blow the fuse, possibly damage the new relay that you put in, and you can possibly damage the magnetron. So it's best to just, leave the unit down if you're not able to replace this waveguide. If you're able to clean it and put it back in and get the machine back up and running, then that's fine. But if you still have contamination in that waveguide, it's better that you just leave the machine down and then return when you can replace both waveguides. This is just the bottom portion of that waveguide. You can see there's still contamination in there. And with this particular job, though, I didn't have another waveguide. I had used my waveguide on a previous job, so with this one, I ended up actually cleaning this one, and I'll show you, and you'll see it in a few. Yeah, this is it here. See, this is the one I cleaned up. So I cleaned up that waveguide, and I was able to get it clear of the contamination on the inside, and get it back into place, and I was able to get it back up and running. But you definitely, that's the clean one. That's the one that I cleaned, and you want to definitely clean those up, and you can go ahead and put them back in there. These are the waveguide windows, right to the on the side wall there. That's the waveguide windows with the seal, and that's what I was talking about when you put in a quote. If you needed to replace the waveguide, you want to replace the window. You don't always have to replace the window, but a lot of times these windows are very difficult to get cleaned up. So it's usually better to just put in a new glass in there. But if you're able to clean the glass and get it clean, then that's fine too. You can just clean it, dry it off, and then put a new seal on there. I do recommend that you put a new seal on it, and then they can be back in business. That's just the other side of the wall, the interior wall of the cook cavity. This area is called the cook cavity, and that's the other glass that's on the other side of that interior wall of the cook cavity. And I cleaned that glass up also. And then once I did that, changed out the K2 relay, changed out the fuse, put a new fuse in there, tested the high volt circuit, tested the high volt transformers, tested the magnetrons, and actually I replaced both magnetrons, and then I cleaned both of those waveguides because I didn't have a replacement on my truck. So I was able to get it back up and running. And once you got that unit powered back up after you finish the repairs, it's always good to go into the program menu and go to your self-test, your test mode, and then go ahead and test out the magnetron to get your amp draw. As you probably can't make it out, but this one is about 17 amps. And like I said, these are older units, so there's probably something going on within the high volt circuit that is causing a little higher amp draw. But as long as I'm not over 20 amps and I'm not under 14 amps, then that's okay. So you do want to do a magnetron test. And if you look at the amp clamp there, you can see that I have that amp clamp around the CT loop wire so that I can get that amp draw reading. And then this is just showing you the top view. Once you got everything installed and in place, you want to go ahead and just do a double check on the wiring that you were testing and stuff like that. Check your high volt transformer wires. Make sure your filament transformers wires are secured, that there's nothing loose. Check your diode wires. Make sure those are all on the terminals that they're supposed to be on. Check your magnetron, your two magnetron wires on each side, and you want to make sure that that red wire is going to the FA terminal. And then you want to check your capacitor wires just to make sure that your wires on the capacitor are secured. And then here, I'm just turn it on, go ahead and let it heat up. These units heat up to 500 degrees. So it takes it a little bit. And with these TurboChef units, once they reach their temperature, they will, when it's a first time startup, like after you've unplugged it and or you've powered it down and then you plug it back in, it's going to go through this initial heat up, and then it's going to do a 7 to 8 minute cook in. And what that, it's going to say cook cycle or cooking. And what that cooking cycle is that's a soak, like a soak cycle. It's so that that stone inside of the cook cavity, to make sure that that stone is at the proper temperature, that that stone is cooked in and that it's at the correct temperature. So that's what that soak cycle is, and that'll come up once it reaches 500 degrees. And then here, that's showing you that soak cycle right there. And then now it's ready to cook. So right here is where you would want to allow the customer to go ahead and cook some food. Make a pizza first. Usually I ask them to make a pizza first, and then after that I'll ask them to cook some of the chicken items, because those chicken items, the proteins and stuff like that, those usually have a longer cook cycle. And if there is still a problem with the machine, it'll come up during one of those cycles. So it's good to do a short cycle like a pizza, which is like a 2-minute cycle, and then do next do like a chicken or a burger cycle, and then use your thermometer after they're done. Once they pulled the food out, use your thermometer to go ahead and take a temperature reading to be sure that the meat products are at the proper temp and that they're not still frozen in the middle or something like that. So you're just checking the operation of it. And that's all I have, everyone. I thank you all for watching. These were some steps that you can use for the repair of a TurboChef oven. And I appreciate you all watching. I thank you for your comments. I ask you to please like, share, and subscribe to this channel if you haven't already. And by all means, take some time to go check out the website, Learn a Trade online, www.learnatrade.online. So that's all I have. I thank you all for watching. I appreciate you. Take care and stay blessed.